Oh, flipping right. Let's do this. I am going to create a canopy somehow. Let's see if we can do that. Let's make a surface. That's the wrong button. Let's make a plane. I'll start at 0 and I'll do it 100, 100. And I'll make sure, yep, that's on. I'm in rendered. Let's go back to shaded. Let's go to geometry, surface. Right click, set one, click. Go to Rhino and hide. Mesh. So mesh tools, utility, mesh surface. Taking my surface and making it into a mesh. I'm going to hide that node. And I'm going to give it some values of around 25, depending on, well, whatever it is we do with it. Subdivisions, 25 subdivisions. Ultimately here what we're going to do is get this surface to act like a tensile fabric, textile material type thing, which is a bit of a rite of passage. The first thing we do in the tool called Kangaroo. And Kangaroo 2 should be pre-installed on your machine. It used to be a standalone thing, but now it comes pre-installed. Pretty complex tool set here. What we're going to do first of all is grab the Bouncy Solver from main, which is here, Kangaroo 2. And what we're going to do is utilize this physics engine to create some gravity, wind, or tension between these lines of the grid here. So that's some, well, we'll explore this together. So let's see. In here, this needs a bit of setup before we can really get going. So let's do that because it is pretty tedious. The other thing I need to do here is called entwine, E-N-T, entwine, and that can be found in sets, tree, entwine, and it's a bit like a merge, or where we can join lots of different datas together, data sets or lists together, and it means that we can also find them, and then we can also unflatten them and unpack them later in their associate levels. But again, we don't really need to know just yet what to do here, but we just need to know that we need to use this tool. And if you zoom into a node like this, you'll see that we've got 3 as default, but I can go in and I can add more or remove them if I need to. So if you see mine a bit later with maybe 4 or 5, you know what I've done there. So that goes into goal objects, and I also need to make sure that I've got an option here to reset. So I'm going to double click and type in button, and that can be found normally in parameters button. And if I go into input, there's another one here called Boolean Toggle. So this works a little bit like a switch. So I can toggle it on with a double click or off. And sometimes, especially when we get a little bit crazy with our creation, we might actually need to turn this off because give our PC a chance to figure out what's going on. Okay, so then when we've done that, the Bouncy Solver will take all of the values that we input. We can reset the values every time we make an amendment, if necessary, and we can turn it off or on. The other thing we need to do here on the O for outputs is what's called if I go back to sets, tree, we can do an unflattened tree. We can drag that into there. And then we can also drag, to make this work, for the entwine into the guide. And sometimes we need to simplify the output. Sometimes we don't. We'll see. The other thing we need to look here as well, on occasion, it might not be necessary for this exercise, but we need to look at tree branch, I think it is. Tree to tree, and then we'll put a value in there of 0. and it's broken at the moment because path 0 doesn't exist because we've put nothing in here. Okay, so this is something that I've done over and over again now, so that's actually a bit of just ingrained memory, like riding a bicycle. Okay, it's just there. I know that I need those things. Sometimes you might not need tree branch, but you might need unflattened tree. We'll figure it out, as and when. So I've got my surface, I've got my kangaroo. Let's have a bit of fun. The first thing, I'm going to go back to Kangaroo 2, and they call them goals, the commands we've got here. So the goal that we might use is an anchor to stop this thing from flying away, because we are going to give it some gravity effects later. So we might need to find some points on this surface to ground our tensile structure. And the points that I'm going to use are going to be the end points of the mesh. So if I go back to mesh, we might be able to find under utilities, is there a mesh corner? It's not in there. Analysis. No, let's see if I can just double click and do mesh corner. Mesh corners. So where do you come from? Doesn't even want to tell me. So I could put the mesh in the from the mesh surface into mesh corners. I don't know what I've done there. Okay, maybe that came from Kangaroo 2, does it? Utility, mesh. Mesh corners. Okay. So, how do I get out of this stupid thing? Discard and close. No, I don't want to save anything. So, mesh corners came from Kangaroo mesh corner. We can see that we've actually got a slightly different thing. So I'll use the one in Kangaroo because that's the one that you guys will be using. And I can drop that into the point on anchor. And I'm going to drop that into 0, 1. Because what I should do as well here is do what's called a show. So in the main show, I can drag in the base mesh and drop that into 0, 0. And that means we're actually going to start visualizing this object. And I think I should be able to hide that preview. Don't really need to see the corners preview. And anchor doesn't really show any geometry anyway. Entwine. And then we've got this guy, the Bouncy Solver itself, which is previewed. I'll view it for now and see what happens. So we've got show on 0, 0. We've got anchor on 0, 1. Let's see if I can remember the next few things. Let's use something called load. Load. And this is going to take, essentially, as you can see this little diagram, it's going to create a gravity on our object. So I'll drag that into 0, 2. And what I need to do now is grab all of these vertices on the inside of my mesh. So we can do that. I don't know if it's under utilities, deconstruct mesh, or is that going to be under, it's common, deconstruct mesh, there we go, analysis, deconstruct mesh. So mesh, analysis, deconstruct, and I can drag the original mesh in there, and you can see that I've got the vertices, 670, loads of faces, and all sorts of information that I might need. The other thing I can use as well is mesh edges. Yeah, there we go. So mesh analysis, mesh edge. Let's see if I might not need deconstruction, we'll see later. And we've got naked edges, which means edges that don't have, naked edges in Rhino mean they don't have anything joining to them. So this perimeter, all these sides of the squares of the subdivision mesh are naked, and all the interior edges are the ones that are not naked. Okay, for use of a better terminology, not 100% sure on the opposite of a naked edge. naked edge. Okay, so we want to merge these together. I wonder if that's in sets. I don't even know. So let's just do merge. That is in sets tree merge. I'm going to take the naked edge and the interior edge, and this is going to do an effect, and we can play around with this because it does do different things. And oh, let's see, maybe actually that's for a different command, isn't it? That's for lines. So I went off on a tangent there, but actually I need to go back into my Kangaroo 2 goals, line, length line. I'll put that in there, and I'm going to drop the spring into, I need to create more, 0, 3. I'm going to reset it, nothing's happening. I'm going to put vertices into points. Holy bananas, look at that. You see that, everybody? Flipping heck. The thing has come alive. That was pretty quick, pretty easy, right? So I did go around the houses, I suppose. Just drag these back out. Do I need this tree branch? I don't need the tree branch at the moment, but I do need the unflattened tree. We might need an unflattened tree. Let's see. So another thing we can add here, let's go into 0, 0 and put another one between it. I can do a grab, which is in main, Kangaroo 2 main grab, and drop that there. Doesn't need anything connected to it. But what that allows me to do is quite amazing. Grab one of these points and pull it around and manipulate that. So this is called a Bouncy Solver because it jiggles. So we've got this jiggly kind of jelly shape physics object. And as you can see, we've got the edge corners, which are the anchor points. And we've got a bit of a load here, which is all the vertices. And we can play around with these values now. So the force vector currently is 0, 0, 1, which means x, y, z. Okay, so it's got a force vector of 1 in the z-axis, and the weighting is 1. So if I can put in a value of, say, 10.00, what does that actually look like? So 1, approximately there. Can I see, drop that all the way down? Where are these points coming from? Let's hide the deconstruct mesh. Let's hide mesh edges and the merge. And let's bring these over here. And what else have we got? If I hide that, I think that hides everything. No, that just hides the points. Good. So the unflattened tree is the geometry here. And maybe again I can put a custom preview. Boom. Looking, flipping, great. Okay, so now if I was to go around here, I can add more density, but the whole thing's going to break, so you need to rebuild that with the reset button. And you can see the animation is quite a bit slower as we've added, well, 50% more points. This thing is breaking, needs to be rebuilt. And the weighting here, you know, can I add more or less? It's looking pretty cool. And then we can also play around with the length line. The length line is the line length between the triangles or the quads. I think these are quads at the moment. Okay, so you've got 4 edges on this triangle, on this mesh, so quad mesh. We can play around with the values here. So the moment length is none, and strength is 10. So if I put a 10.00 in there again, well, actually I'll do a 10.100, and that will give me more values up to 100. So strength, I believe, is like the rigidity of those lines. So if strength is set to 10, it means the lines themselves have got a bit of flexibility between this one and the next one and the next one. So you kind of get that organic cloth looking effect. But the more strength we add, the more rigid these lines become, and you actually get some, interesting and exciting things to play around with here. It's certainly a little bit later. Doesn't look too bad. What happens if I put 1,000 in there? It's not overly happy. Well, I'm not too sure what those numbers do because they all look the same to me. Yes, and we can play around with these different things. How cool is that? Can we go back to revealing our original surface, pressing control points on and moving those points around and rebuilding. I wonder why. Oh, I've got two surfaces there. Okay, just make sure we do a little rebuild. Yeah, so we do have a bit of opportunity there to go in and create our own footprint or boundary with that model. We check my notes and we'll go in and see what else we can play around with. Because I'm drawing a blank. Okay, let me go back a few steps and we'll stick to 100. Reset that and I'll bring these nodes back to 25 each. And I'll hide that surface again. Just to give us an idea where we were there. Okay, so yeah, I've got the force vector. Let's play around with this. So I'm going to make sure that I retain my z-axis here. So unit z in the force vector of the load. And let's see what numbers I've got here. So it was 0, 0, 1. Let's try 1.00, 1.01. So that'll give me a value up to 10, I believe. Yep, with a decimal place. So if I take that to 1-ish. This is, making sure that value is combination of these. So one thing to note as well is if we start playing around with these numbers and all of a sudden it looks like our work is broken, you can delete the inputs and it goes back to all the default values. Okay, so don't worry too much about those things being a bit of a problem. And the jiggly wigglies around, I'll put those back in there though. Guess I won't. Edit, redo, can't, okay, should just undo Z. Okay, so another thing we can play around with here is turning those quads into triangles, and that will create a slightly different effect that we can control on this surface. And this will pretty much conclude round one of this exercise. So what we need to do is, as a concept, is explode this original mesh, and using these edges that we've got here, is create, extract the endpoints of all of these lines, and then find the correct one, the opposite one, and join them with a line, and then rebuild the mesh. Or at least give those some length line values here so we can play around with some strengths. Okay, so let's just drop some tools on the canvas first of all. So the first thing I said was to explode the mesh, so let's see what we've got there. Mesh utilities maybe. We've got mesh join. Mesh explode is under analysis. Okay, mesh explode, and then so let's take that into there. Is that the right mesh? I might be. Let's see. We need to deconstruct that further. deconstruct, I can't type, the mesh. And that's going to give us the vertices of all those exploded objects. What else do I need to do here? And now, as I say, I need to find the corresponding endpoints from these things. So I've got all the vertices here. I've got 2,500 of the flipping guys. So what I need to do is to find the index of, so if it's 0, 1, 2, 3, to draw a line between these to make them triangles, I want 0, 3, or I want 1 and 0, 1, 2, 3. Yeah, 1 and 2, or, oh my gosh, 0 and 2, or 1 and 3. Okay, and to do that, I use a list item. So the list is the vertices, and let's see if I can just get around that without having to do much complex unwrapping or unraveling. So the first thing I can do here is look at the line. So in the last session we used start point, tangent and length, SDL, but this time we're just going to use 2 points. And here we are going to create, so if I go 1, 2, 3, essentially these are all my points of my triangles here. So index 1 to 3. So can I create a line from there and there? Yes, if you look at my mesh, I've now got diagonal lines. Looks like individual, but they are all exploded. So if I copy and paste that, you can see now that I've got these triangle forms, which is looking pretty good. And what I need to do here is create a couple more length lines. So let me disconnect those lengths. Okay, so I've got a line at the bottom and a line at the top. And I'm going to drop those into the entwine and add a few more nodes. Ooh, and you can see what happened there. So even with that one direction of lines, it kind of collapsed my tensile structure a little bit more. And yeah, it is adding a few options. Well, what is it doing? I guess it means it can deform in more ways because the triangles actually allow it to fold in the center. And one thing we can look at here is the length of that. So again, the length is set to nothing, I believe, as a default. So let's see what happens with 1.50. So it's compressing those lines. Let's reset it just in case that broke it a little bit. No, that's looking pretty amazing. If I just quickly bake this out, just to get a real value. Okay, so they are actually, there we go. Ooh, I wonder what it's doing there. Let's undo that bake. Let's do this one. Alright, it really just is exporting all of those curves. But we need the mesh. Come on, you stupid thing. I don't know why I can't grab that. That's quite frustrating. Why can't I grab that? I've still got grab on. It's cool, isn't it? Look at that. Okay, so let's see if I can bake this. They're still coming up with nodes, aren't they? Okay, so clearly this is proving difficult. What I can do here instead is drop in a mesh node, and that would be from parameter, and drop that into unflattened tree. from the object. Okay, that's being a pain. Why can't I grab it? From line to mesh. Do I need to do a construct mesh? Thought it was going to be too good to be true. Okay, so let's There's definitely a mesh there. One open mesh added to selection. Move. There we go. Oh. Okay, so maybe that was not allowing me to grab it because I've got grab on here. So if I was to do a disable, yeah, I can grab it very easily. So it didn't know if I was going to be grabbing the mesh or the visualization of this tensile structure. All right, so let's get rid of that. Let's get rid of you. Let's enable. Yeah, disable grab. Don't need to grab anyway. Okay, cool. Glad I figured that out a little bit anyway. Delete those baked points. What we want to do, yeah, is play around with those. So what I can do, I suppose, is bake this out, and we'll see what we've got as a default structure. Oh my gosh. Did I actually do that? Mesh, yes. Okay. And what we're going to do now is put that value back in, which I think I deleted. Watch that, have a bit of fun with that. Bake this out again. Okay, so that's just adding a length line of 1, and you can see that I've got these quite triangulated forms now in one axis only, one direction. How cool is that? So if you've got these like weird random rendering artifacts, you can do unweld in Rhino, unweld mesh, or unweld, and an angle tolerance of 0. And that might get rid of some of those crunchy edges. So yeah, really looking quite exciting there. What happens if I drop that same, well, slightly different number maybe, into the other line length? There we go, it starts to flatten out a bit more again, but we do get some cool forms to play with. And maybe I'll give it a little bit more Z. And yeah, basically you can play around with here and see what happens. So the more you give it there, the more inflated essentially it becomes, and it's more difficult to kind of determine what is going on with that. There you go, that's cool. It just kind of happens on the surface there. That's a really nice effect. That was cool. Bake these out. So it is exporting all the points from this deconstruct mesh, I suppose. Where are these points coming from? The list item. That's looking good. Okay, what else can we explore here? We could do something a little bit more fancy with these values here. So let me go and do a length of the line and a simple multiplication. So I'll go back to, I'll keep in here, I won't bother with the shaded. So what I want to play with here is find the length of each line. So that's probably under curve analysis length. So I can drop that into there. And I'm going to do a multiplication. A, and the values I'm going to put in are these sliders. I'm going to drop that instead into there. So let's organise this a bit more. Let's bring it all the way down for now. Let's see if I can copy the. What's going on? Copy these to here. Put that line in the curve. Put in the length. Okay, so now we've just got a little bit more. Okay, look at that. We've got a bit of a twist effect happening now. So it's adding more tension into one axis than the other. Actually, if we go higher than there, we can really start to explore. Oh wow, look at that. It's kind of two lines lengths in tension. But you can get a few problems here where all your triangles are really going to get grouped together and not have that fun a time. Let's bake this out. So I'm still getting all that surplus geometry. Seems to have grown quite a lot. I'm just doing a drag over half using the left to right drag. See if that unworld works on here. Alright, unworld made that a little bit knobbly, so I'm going to go back. Alright, so I think for the lulls we can group these. And you can name these accordingly. Looking cool. Okay, what else could we do? We could try a little thing here with some more of these kangaroo forces. A few things that I've looked at in exercises. Well, these different goals, using the length line, and having some of these really, what were they? I don't know, can't remember what they were now. Equal length, yes, so it makes all those lines quite rigid. I think, yeah, let's see if I could do, I can't remember what they were called now. I don't think it was equal length. But anyway, let's see what that does. If anything. 1. Doesn't seem to do anything. A few things I looked at was, yeah, you could put a bit of pressure in there and essentially thicken this object as if it was inflated, which is quite a fun exercise to do. The other thing I looked at was, where is it? Wind. Here we go, look. Oh, I did do some vertex loads. Alright, so anyway, let's grab this mesh, the original mesh. Wind vector, so that's the direction. So let's go in the X direction. And the value at the moment is set to just 1, I think. So let's use that same slider. No, I do a 10.01. So it's 2 decimal places. Drag that into the X factor. And then put that into the wind. And the wind is going to go into entwine. And what we'll see is this object in X respond to a bit of a gale force. So this is at 0.6 at the moment. It's a nice bit of breeze. And now we're kind of increasing those values up. And as you can see, he's really taken a battering. We should be able to, at any point, bake this out. You've got more of a organic wavy structure there. Looking at that, it's flipping amazing. Let's soften that up a little bit. Okay, so going from there, we can do Weaverbird stuff really. So if I go to Weaverbird, we could do a picture frame. What should we do? Shall we do a mesh thicken first and then a picture frame? No, let's do a picture frame and then a mesh thicken. So it's not that, it's this. And the distance at the moment is set to 5, I think. Yep, so let's do 15. Why is that broken? Must be made of meshes or closed polyline. Well, it seems to be working, so maybe I can take that into... Yeah, okay, I'll take it from output instead. I'll hide the unflattened tree. And the mesh from the custom preview, I can keep dragging that along. Look at that, it's pretty cool. The other thing we can do here is the mesh thicken. At the moment distance is set to 5, so I'll take that same slider, copy paste, drag and alt. Alright, so that's a little bit too thick here. So there's a problem where now, because we've not so bad here, but if I'd have gone really tight with the edges on this multiplication, you might experience twisting or intersections. It's not too bad. It's good. And then I can do that Catmull Clark under subdivision. We've got a few here. Got Catmull Clark, which is the classic, and we've also got Sapinski triangles. So maybe we could use Sapinski triangles, if that's how you pronounce it. It looks like it is, because we obviously made our surface now. Sorry, our mesh triangular. So levels go, I believe, again up to 3. Let's hide that. Let's hide both of these. Let's put the geometry in here. Oh no, so it's not that, is it? That's the wrong one. Okay, well let's play with this one first. Let's go whack that straight up to 3 and see what we get there. That's fantastic. Pretty dense mesh that we can change on the fly depending on our hardware. Create these kind of coral structures. go back to this delete, try sorts of things, but you can get around there and play around with those. How cool is that? We've got a bit of system lag now, as we've got all these things happening all at the same time. If you do get it, play around with just number 1, for example, on the subdivision, make things a lot smoother. You'll get a gist of what's going to happen, but actually you're a bit, your PC might be able to handle that a bit easier. So bake that out. For the purposes of a bake, I will increase the poly count. Bake that, okay. Give that 5 minutes. Fantastic. And then I'll drop that back down to 1. Can disable the preview, just so we get the geometry. Looking flipping good. Let's see, we've got a bit of a kink in there. Alright, so yeah, it's managed that quite nicely actually. Apart from there. Yeah, so that's not going to cause us any problems for this project, but in some circumstances that might not be applicably or useful. So we've come quite far, haven't we, from our base object, which was just a rectangle. Put it into Kangaroo. We gave the vertices on the inside, we merged them, the edges, gave them some value in Z, anchored the corners, and gave those a bit of wind. We turned them into triangles instead of quads, and then we explored those options available to us, and then we went into Weaverbird plugin and extracted and created these cool Catmull-Clark subdivisions. And I don't know why my brain has gone completely blank onto the other options we've got. Is it just that? Is it as simple as that? Or maybe it's even before the picture frame, isn't it? It would be before the picture frame. So let's take that guy, drop it into the mesh, and drop that into the picture frame. What have we got here? Super triangulation, which is not what we need. That's pretty cool. Wow, that's really happening on all of those triangles, isn't it? This is how you break your computer. All right. And this is a problem actually with Bouncy Solver. So you can do a different Kangaroo solver, just called Solver. And that will, or even Zombie Solver, it will do all the calculations and it will just give you the value at the very end. So maybe that's something to explore here. Cool, cool, cool. Till next time.